Welcome to Saitechinfo, my dear students. In this session, we will discuss about the scattering of light. So when you look at this phenomenon, that is the scattering of light, there are three important properties associated with that, and these are all the important features of light. One is Tyndall Effect. The next one is why the clear sky appears blue. Then color of the sun and sun, especially at sunrise and at sunset. We will discuss these features one by one. Let me start with Tyndall effect. See, Tyndall effect is, you could have seen in dense forests, you can see the beam of light, that is sunlight, very clearly. This phenomenon is due to the Tyndall effect. The Earth atmosphere consists of minute particles such as smoke, tiny water droplets. Then there will be some suspended particles of dust, then molecules of air. In fact, all this put together are called atmosphere. When a beam of light strikes these particles, dust particles, or water particles, etc., the path of beam of light becomes so visible due to scattering of light. So this phenomenon of scattering of light by the colloidal particles, so its particle size will be in terms of nanometer. So this is called the Tyndall effect. So these particles, they scatter the sunlight, and it is because of that you are able to get this beam of light, especially in the dense forest. If the particle size is smaller, then it scatters blue light, because shorter the wavelength of visible spectrum, more will be scattering. Then if the particle size is larger, then it scatters a red light, because red light has higher wavelength. So if the size is much larger than the scattered light, then it may appear white. You understand? Now, air molecules are smaller than the wavelength of blue light, so in the visible region. Okay, so that is why we are able to get this pattern of light. Now, let us discuss why the clear sky appears blue. When the sunlight passes through the atmosphere, blue light is much scattered, as I already discussed, by the atmospheric particles. So the clear sky appears blue. Then red light is often longer wavelength, is of a longer wavelength. Red light has longer wavelength. How to represent the wavelength? Lambda. Okay, so for a red light, it is longer. The red light is having longer wavelength than that of blue light. Okay, now it is not scattered by the atmospheric particle. So the sky appears dark when the passengers are flying at very high altitude. Why? Because there is no scattering of light at such a prominent height. Okay, then let us discuss why the color of the sun appears to be red orange, reddish orange during sunrise and sunset. The sunlight near the horizon passes through thicker layers of air. Therefore, blue light being shorter, so we discussed already that is a blue wavelength is shorter than a red wavelength, is it not? Red light wavelength. So it is immediately scattered, and red wavelength is longer. It can travel a longer range. So it reaches red. That is only red reaches us, and that is why it appears red. Sun nearby overhead at moon is relatively at a shorter distance, and therefore less blue light is scattered, hence sun appears white. So these are the valuable reasons for such kind of phenomenon. Then let us talk about this phenomenon, that is uh, twinkling of stars. Twinkling stars. We used to sing the rhymes, twinkle, twinkle, little star. So here, why the stars are twinkling? That is our analysis. See, the twinkling star is due to the atmospheric refraction of starlight. So, you know very well the star is too far from us, and there will be definitely some atmospheric refraction. Okay, so as it passes through the atmosphere to reach us. When the starlight enters into the Earth atmosphere, it undergoes refraction continuously, because it has to travel a long distance across the atmosphere before reaching Earth. So down the Earth, the refractive index increases. How to represent refractive index? Mu. So the mu down the Earth, it increases. Hence, the refraction of starlight changes. So there is a change of refraction. Do you understand? Now, so as it descends, as it comes down, now the refractive indices are changing, is it not? So the refraction of starlight is also changing. Since the atmosphere bends the starlight, refraction is nothing but bending of light when it passes through different media. That is the path deviation. So towards the normal. So the atmosphere bends towards the, since the atmosphere bends the starlight. So starlight now it bends towards the normal. So when it bends towards normal, the apparent position of star is slightly different. So it appears to be shifted from the actual position. So see, this is the actual path, but now there is a shift. There is a shift here. That is the apparent position. Okay. Now the apparent position is not stationary. Not only that, this is not stationary. Once again it comes back. Once again it goes. Once again it comes back. And that is why there will be a star fluctuation with a shorter distance. So when it enters our eye, it flickers. Are you able to follow? Since the apparent position of the star fluctuates, so this position, apparent position, original position, apparent position, there will be a fluctuation, and the amount of starlight when it enters, then it appears to be flickering or twinkling. Okay, so this star now appears to be brighter and fainter, and this occurs frequently. So that phenomenon is called the twinkling of star. So what is twinkling of star? It is the phenomenon of that is appearance of a brighter and fainter stars frequently. Okay, so it goes on changing. Sometimes it will be brighter and sometimes it will be fainter. Okay, lighter, brighter, lighter, brighter, and that is the twinkling of star. So it is due to what? The refraction, the changes of refraction down the earth. Are you able to understand?